Okay, here is what was assigned 10b, problem number 9. Consider this circuit shown in the figure below where C1 equals 6 farads, C2 equals 7 farads, and change voltage equals 22 volts. Capacitor C1 is first charged by closing switch S1. Switch S1 is then open, and then charge capacitor connected to the uncharged capacitor by closing S2. Calculate the initial charge required by C1 around answer. Okay, so this is pretty straightforward here. So it did say that S2 is closed, therefore our only concern right here, I'll draw it, is, oh shoot, I already messed up. Boom, boom, boom. It's this circuit because, this one's closed, therefore charge cannot, charge cannot exist in a state over here. Okay, so this is what we're looking at. C1, and we know C1, what was it? 6 hertz, and change voltage 22. So here we're going to use our equation that capacitance is equal to charge per voltage, and then manipulate it. So the charge is equal to capacitance times voltage, and because we only have one capacitor that we're looking at, because that's the only switch that's closed, it's just going to be those 6 farads. So charge will be equal to these 6 farads times our total voltage, which is 22, right? 22? Yeah, 22. 22 volts, and that gives us a charge of 132 times 10 to the negative 6. Cool. And that would be our answer right there. Calculate the final charge using capacitor. Okay, so now we do have to take into account that capacitor. But seeing as we just found the charge for the first one, that charge is going to be constant for both. I hope that kind of makes sense. That charge being delivered to each capacitor will be the same because they are in parallel. So we're going to use that charge here. So make sure we know where we're at. So it'd be, so for C1, its charge is going to be equal to its capacitance. So C1 times this charge that we just found, all over total capacitance. And that would be the same thing for C2. So these answers are going to be very close to one another. Once you fill in for C1, we'll get Q1 is equal to 6. I'll do the sig figs here. 130. Okay, 132. These guys. That's not a unit. All over was at 13. Yeah. All over 13, because that's the sum of them. And then you do your little, these things cancel, so then we're still in, those farads. So Q1. So this 60.9. These guys. It's farads, right? Yeah. No, coulombs. How do you get the coulombs? Oh. I made a mistake. Coulombs. Coulombs. There you go. That makes more sense. And then, once we're substituting the same process for Q2, we get 71.07. Again, that's a very close answer to before. So common mistakes here would be not reading into the lines that this circuit is closed here for the first part, so we only have to worry about the first capacitor. Second line mistake would be not using the charge from our first, from part A and using that for part B. What else could we have done wrong? I mean, it's looking back, I'm sure a month ago when I was supposed to do this, it would have been a lot more complicated. But, seeing as we have done more stuff, and that's kind of the good part about looking back sometimes, is realizing how far you've come. This was a question I didn't even answer the first time for the website, because I thought it was difficult, obviously. But looking at it now, I just went through it in about 5 minutes, and I think I went thoroughly enough. But, another challenge would be just make sure you watch your units and your conversions. But again, here was pretty straightforward with your units. You didn't have to really convert anything at all. Just recognize when it says the circuit's closed, that means that all the things that attach to or loop it back to the battery are not applicable to the equation at that moment. And yeah, that's it.